Okay, so we're going to be continuing our VSEPR and molecular geometry example problems. So like I said before, I would work through set 1 notes, work through these notes second, and then I would do the practice problems. Okay, so we're going to start off by doing our Lewis structures. P, we have one P, and P is in group 5. Okay, chlorine. We have 5 of those, and it's in group 7. 5 plus 35 is 40 electrons total, so I should have 20 bonds. Okay. So, I'm going to put P in the middle, and I'm going to put 5 Cl's coming off of it. Okay. So, gonna look something like that. Now I gotta go fill in my electrons. So chlorine is usually gonna have 3 lone pairs, so I'm gonna put 3 lone pairs on each one. And then phosphorus has to have 5 electrons, so it has 5 bonds. So this is your Lewis structure. Okay, so if I'm gonna do my electron, what did I say? Electron geometry, the last one. And then we're going to do molecular geometry. Okay, so we're going to go to our chart. We have 5 bonding domains. 1, 2, 3, 4, 5. 5 bonding domains, okay? Now, when we do this, we're going to look at the back of our chart. Okay, so our electron geometry is trigonal bipyramidal. In your molecular geometry, we have 5 bonds and 0 lone pairs. 5 bonds, 0 lone pairs. It's going to be trigonal bipyramidal. Okay. ClF3. Okay, so chlorine, we have 1 chlorine. That's in group 7. Fluorine, we have 3, and that's also in group 7. That's 21. Add them down, you get 28. So we should have 14 bonds. Okay, so chlorine is going to be your central atom with 3 fluorines coming off of it. Okay, remember what I said, fluorine and the halogens are usually going to have 3 lone pairs of electrons. So let's start off by doing that. Okay, now chlorine has to have 7 valence electrons because it's in group 7. So it currently has 3, 1, 2, 3. So I'm going to put 2 lone pairs of electrons coming off of this. And it doesn't matter where you draw them, you know, just as long as they're there. Okay, so that's our Lewis structure. So let's make sure we got it right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we're good to go. Your electron geometry. And your molecular geometry. Okay, so we have how many bonding domains? We got 1, 2, 3, 4, 5. Okay, so we got 5 bonding domains, 3 bonds, and 2 lone pairs. Okay, so 5 bonding domains were in trigonal bipyramidal. In your molecular geometry for 3 and 2 is T-shaped. Okay, so SF6. Okay, sulfurs, I got 1 sulfur, it's in group 6, so we got 6. Fluorine, I have 6 fluorines, and I am in group 7. So it's 48 electrons. 48 divided by 2 is 24 bonds. Okay, so sulfur is going to be my central atom. Okay, and we're going to have fluorines coming off of them. Like that. Okay, advice I gave you, fluorine's probably going to have 3 lone pairs of electrons. Okay, so we're going to do our electron geometry. And our molecular geometry. Okay, so we have 6 electron domains, 1, 2, 3, 4, 5, 6, and 0 lone pairs. So it's going to be octahedral and octahedral. Okay. Okay, next one. Xenon tetrafluoride. Xe, I have one of those. Xenon's in group 8, so I have 8 valence electrons. Fluorine, we got 4 of those, and that's in group 7. 8 plus 28 is 36. Divide that by 2, should be 18 bonds. Okay, so Xe is going to be your central atom with 4 fluorines coming off. I don't know if y'all have noticed, but the thing that has the least amount of, like F4 in this case, I know those have to be coming off the Xe, you know, so the Xe has to be the central atom. Okay, so fluorine's going to start with 3 lone pairs. Xenon is in group 8, so it has to have 8 valence electrons. It currently has 1, 2, 3, 4. Okay, so it needs 2 lone pairs to complete the octet. Okay, so okay, so we have 6 bonding domains. 1, 2, 3, 4, 5, 6. So we go to our thing. 6 bonding domains is going to be octahedral. Now, we have 4 bonds and 2 lone pairs. So 4 bonds and 2 lone pairs is going to be square planar. Okay. Okay, let's look at this one. It's a little bit different. AlCl6 with a -3 charge. Okay, so aluminum, we have 1 aluminum, and it's in group 3. Okay, so in group 3, so 1 times 3 is 3. Chlorine, 6 chlorines, that's in group 7, that's 42. Okay, so it's 45, right? It has a -3 charge, so that means it gained 3 electrons. Okay, so 48 electrons. That means we should have 24 bonds. Okay, so this one's going to be a little bit different because we've got this charge to deal with. Okay, so aluminum's going to be the central atom. Okay, so I'm going to put my chlorines. And I'm going to put my 3 pairs of electrons on them because that's what usually happens with chlorine. Okay, now this is something called violating the octet rule, because the octet rule says that you're supposed to have the number of bonds is the same as the number of valence electrons. Okay, so this would violate the octet rule. Okay, But see, you got 1, 2, 3, 4, 5, 6. So it's supposed to have 3 bonds, but we have 3 extra ones. So that's where we're going to get this -3 charge. Okay? So your molecular geometry, electron geometry. Okay, so our electron geometry and then molecular geometry. Okay, so your electron geometry, we have 1, 2, 3, 4, 5, 6. So it's octahedral, and there's no lone pairs, so it's octahedral again. Okay, last one we're going to do for the notes. Sulfate ion, okay? So sulfur. Sulfur has, we got 1 sulfur, it's in group 6. Oxygen, you got 4, it's also in group 6, it's 24. That's 30. Now, it has a -2 charge, so we add 2 electrons. So we get 16 bonds. Okay, so when we get 16 bonds, you're going to have sulfur with 4 oxygens going on. Now, going with what I told you earlier, oxygen's going to have 2 lone pairs of electrons. Okay, and so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I need 16 bonds total. 11, 12, 13, 14. Did I count that right? Let's count that right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that gives me 16 bonds total. So that's going to be my Lewis structure. Now, sulfur is supposed to have 6 valence electrons because it's in group 6. It has 8. Okay, so this is going to be a violation of the octet rule. Okay, so for certain Lewis structures, that's okay. So it's going to be most stable like this. So it's going to have a -2 charge because it has 2 extra electrons. Now, if you're looking at this stuff online, especially for like these 2 things, you're going to see something called resonance structures. And it's really not worth teaching right now because it's kind of complicated, but they'll switch between Lewis structures of certain stuff. The bonds will switch up and, you know, like in this case right here, one of these pairs of electrons might form a double bond, and your -1 charge would be over here or something like that. So if you want to look that up, be my guest to look that up. I'm not going to make y'all do that. That's kind of a organic chemistry, college chemistry thing. Okay, so we have 4 bonding domains. 1, 2, 3, 4, because double bond counts as 1 bonding domain. So we're going to go, and it's going to be tetrahedral, and 4 and 0 is going to be tetrahedral also. So tetrahedral, tetrahedral. Okay, so the prefix tetra means 4, so that one's pretty easy to remember. Let's see which other ones are easier. The linear one's pretty easy to remember. Other than that, those are kind of, the rest you just kind of got to memorize. There's no easy way to do this stuff. Most of the time you're going to be living in the 4, 3, 2 range. You might have some 5, 6, you know, electron domains, but you know, you have the chart in front of you. So if you have any questions on this, feel free to reach out. Hopefully this helped you out. And if you have any questions, just shoot me a text message or email. Have a good night.